Hello and welcome to Module 2 of the No-Code Blueprint, the software development lifecycle. So there are a few key things that we're going to cover off in this module, and we're going to cover off things like ideation, so how you come up with your idea, requirements definition, design, build of your product, testing your product, publishing your product, more importantly, driving adoption of your product, and then finally we'll end off by comparing some key software development methodologies. I've purposely called these activities rather than steps because of those different methodologies, as I said, we'll cover those at the end of this module. So let's get started on step one. Everything starts with an idea. And there's so much that can be said about coming up with ideas for a software product that it would be a course on its own, and there are courses on their own. With many varying methodologies even for thinking of ideas, things like design thinking. So unfortunately it's beyond the scope of this lesson, or in fact this course, to go into any detail around ideation. But the key thing to bear in mind is that you need to look for a problem to solve rather than building something and then looking for a problem. This means that you'll need to validate your idea, and this should be done before you invest huge amounts of time, effort, or money in building a software product. So many people take the wrong approach, build it first, and think that people will just come and use and buy the solution, and often the solution just becomes a white elephant, and as I say, time, effort, and money is wasted. So the three key steps there are: one, identifying a problem, then proposing a solution, and then validating that solution and iterating on it. So very much think about building a minimum viable product before you kind of build out a full set of features. The next activity that you're going to be doing is a requirements definition. So having hopefully validated your idea, you can now begin identifying and defining the broad requirements of your proposed solution. Requirements are generally made up of two key sorts of requirements, and the first are functional requirements, and those really are the features and functionality of your application. So for example, the ability for a user to register an account, or the ability for a user to log in, the ability for a user to display their transactions. Then the next group are non-functional requirements, and these are typically things like the performance requirements of your solution, security requirements, availability requirements. So, I might want to run a report. It should take less than 6 seconds or 10 seconds or whatever it is. Now, requirements are often written up as user stories in the format of the example you can see there. So as something, I would like to do something so that I can achieve something. So an example of this would be, as a user, I would like to register my account so that I can securely access the platform. And this format of establishing and writing out user stories, it works very well because it describes not only the required functionality but also the business context, and this makes it a lot easier for technical teams to understand and implement. So it really is about understanding that outcome that the business user or general user of the public is looking to achieve. A widely accepted way to manage requirements is to create a backlog of user stories, which effectively then describe out all of the functionality that you need in your application or your product. These are then stored in this backlog and are used to then manage the process through the software development lifecycle. And we'll talk a little bit more about this in the last section of this module. But the key takeaway here is that you'll need to process to manage your requirements and ensure that what was asked for or proposed is in fact what gets delivered at the end of your software development lifecycle. Next, you'll need to think about the design of your application or solution. This happens in the same way that an architect will design a house. So you should design your software before you build it. In fact, that is why the relevant role is often called a software architect. The level of detail to which you design your software will be dependent on the methodology that you use. But broadly though, and you should know this already, you'll need to consider the following. 1, user interface design. 2, the business logic or application logic design. And finally, the database design. Now, these all tie back to some of the points we spoke about in the introduction. And if you remember the last software architecture we spoke about, These will all be covered in more detail in a subsequent module. So really, if you work on the house analogy, you can think of, the broad idea is somebody needs somewhere to stay. Possible solution is a house. The house should have 2 bedrooms, it should have a living room, it should have a kitchen, and it should have a garage. Now those are all requirements. The architect will then take those requirements and build them into a design to get approved before that house gets built. So think about it in that way, and that really describes, I think, the sequencing and why it is important to sequence things in that way. Right, so building on the software product begins after you've done your design. And again, there are many methodologies that can be used to manage the build of your software products, and we'll cover the basics at the end of this module. Essentially, though, this activity covers the actual creation of the software product, including the user interface, the business logic, as you would have guessed, the database, and also any other peripheral components. Next, and very, very important, is the testing. This is potentially where a product either succeeds or fails. And testing generally takes place after the build of a product, but in reality, though, it's sometimes impossible to separate this activity from the build activity, as the two are very closely coupled. There's various types of testing that should take place, and these generally are unit testing, which focuses on testing the components of a software solution, often in isolation of any other components that are being built. These are often performed by the person who creates that specific component, but should ideally be performed by a peer on the project, just to ensure that there's no kind of blind spots. Integration testing next focuses on ensuring that those various software components function correctly together. So once they've passed that unit testing, the integration testing takes place. Next, you'll want to do some functional testing, which ensures that the business-specific outcomes are met. So those requirements that have been articulated, either by you designing the product or sort of shaping up the product, or by a customer or a user asking, have they been implemented to the customer's satisfaction? Does it meet the outcomes they were looking to achieve? Then end-to-end testing really replicates how a user might work with the software application. So making sure that everything flows and hangs together as you expect it would. And then user acceptance testing, which are generally formal tests to ensure that the system meets those specified requirements set out by the business. Typically something which is signed off. And then there's also an element which sometimes gets used called smoke testing. And these are just tests that are very basic and applied to software products, often to decide if there's enough in place to do a more formal test. So for example, before proceeding into user acceptance testing. And then finally, non-functional testing, and that makes sure that the solution meets the non-functional requirements that have been set out. For example, the performance of the solution, which we covered in an earlier example. Now, it sounds like a lot, and these are generally the formal processes that big software development or even smaller software development teams take. Again, in a no-code environment, you probably won't do all of these, or they might not be as broken down into sort of components. You'd probably just do kind of one lump of testing. But I think still important to note, even although you are using no-code, it's still very important to test. But I think the key takeaway here for you is to be aware of the different types of testing, so you know what to look out for when you test the software that you develop yourself. Once you're happy, of course, with your software having passed all of the tests you set, so that's either passing user acceptance testing or the equivalent that you've established, you can now publish your software into a production environment, or in fact release your software to the public. In the real world, you'll probably release a beta version of your product first as an early release with a limited number of users to get some early feedback on your software. And this will really help you iron out any major defects before fully releasing your software. Next, and very, very important, is the critical activity that many software development projects neglect. And this is the activity to drive user adoption of the software. In the consumer world, this seems to be less of an issue, as there are often onboarding or customer success activities in place, such as training and video guidance. In the corporate world, though, this is often neglected. So again, very importantly, if you're developing a software for a solution for internal use, you need to think about what those activities are that'll drive the adoption and how people get using your software. If you're publishing a consumer type product or software solution, again, think about those activities to get customers onboarded using the solution and getting value out of your solution. Because if they don't get value out of your solution, they'll unsubscribe or worse, ask for their money back. Now, we're going to cover off a couple of development methodologies at a fairly high level. And broadly, we're going to separate these into two. The one is waterfall methodology, and the second is a group of methodologies called Agile. So Agile is really a flexible and iterative approach to software development that emphasizes continuous delivery, collaboration, and adaptability. There are various flavors available, such as Scrum, Kanban, Lean, and Extreme Programming. A commonly used approach is Scrum, which is based on performing several fixed length sprints, could be a week, could be 2 weeks, could be 4 weeks, that look to deliver something of value at the end of each of those sprints. And the benefit of this is that it promotes frequent delivery and progress. It gives a bit of flexibility and adaptability, and it's also really well suited for large, complex projects. It does have some drawbacks in that it can be more difficult to manage if the team's not fully committed to the process. It requires strong leadership and communication to be really effective. Agile delivery is generally more expensive than waterfall, but does generally provide a higher quality product. So to get started, I recommend taking an agile approach. I typically use Kanban, where I create a board with various columns which dictate the sort of steps of the progress of each of my components. And the idea is to move a user story as smoothly as possible. Remember, user stories from inception all the way through to completion. What I'll be doing is a bit of a demo of this at the end of this module, so you can see how I manage my workload and products and projects. So a little bit more about the two methodologies. Waterfall, which I didn't really cover off in much detail in the last slide, is a traditional linear approach that follows the previously described activities. So one step must be completed before the next begins. And this approach can work well for a small project where the requirements are well known, but a drawback is that it can be inflexible and doesn't really allow for changes to the project once it's underway. When used on larger projects, it can mean that when it comes to actually delivering something, the circumstances and requirements have changed and the product does not necessarily meet the mark. So this would mean you would determine all your requirements, those would be signed off. You would then go into your design, that would be ticked off, and go into your build. Should something happen that changes things, it's really difficult to adapt because you've gone through those formal stages before. Now, this type of approach works well in some circumstances. I would say, like building a rocket, for example, or putting a man or a person into space. You wouldn't want to do that in an agile way. But from a software development point of view, Agile, I feel, really is the way to go. So looking at a little more detail in terms of Agile, as I said before, it's a flexible and iterative approach. It does have some drawbacks, as we mentioned. It is more expensive than Waterfall, but does provide a higher quality product. And as I say, I do recommend it as the way to go. And the next part of this module will really be a demo of how I run that Kanban board, which makes it really easy to track progress and monitor where I am. So see you in the demo.